Okay, let's do some SAT quick math. In this problem, we could see that we have x plus 3 on both sides of the equation, and we want to know what is the value of x plus 3. So x plus 3 can be our common term, and we can actually treat it as a single unit. Therefore, instead of distributing or any other technique, we could actually subtract 2 times x plus 3 from both sides of the equation, and it will look something like this. We'll have 6 times x plus 3 minus 2 times x plus 3 is equal to 48. From here, we can combine like terms, so we're left with 6 minus 2 times x plus 3 is equal to 48. From here, we are left with 4 times x plus 3 is equal to 48. And then we simply divide by 4 on both sides of the equation, which leaves us with an answer of x plus 3 is equal to 12. Again, we don't have to worry about what x is equal to. We're focused on what x plus 3 is equal to, which is 12. Okay, let's do some more practice SAT math problems. Again, when we look at this problem, it's asking us what is the value of x plus 2? And so what we have here is a single variable linear equation, and we actually have the same binomial expression x plus 2 on both sides of the equation. Therefore, we could treat x plus 2 as a single unit. And to solve this quickly and accurately, we can actually subtract 6 times x plus 2 from both sides of the equation. So we'll be left with 10 times x plus 2 minus 6 times x plus 2 equals 32. From here, we combine like terms, so we are left with 10 minus 6 times x plus 2 equals 32. And before I continue solving this problem, if you're enjoying videos like this, please be sure to hit that like button and subscribe to get more daily tips for SAT, ACT, math, reading, and writing questions. So now we are left with 4 times x plus 2 equals 32. From here, we just divide by 4 on both sides of the equation, and we are left with x plus 2 equals 8. Let's do another single variable linear equation. When we look at this problem, we could see that we're trying to find the value of x minus 2. When we look at this closely, we could see that we have the same binomial expression, x minus 2, on both sides of the equation. Therefore, we could actually treat x minus 2 as a single unit. So instead of distributing or any other technique, we could actually subtract 3 times x minus 2 from both sides of the equation. So we're left with 5 times x minus 2 minus 3 times x minus 2 equals 14. From here, we can combine like terms. So we are left with 5 minus 3 times x minus 2 equals 14. And then we are left with 2 times x minus 2 equals 14. From here, we just divide by 2 on both sides of the equation, and we are left with x minus 2 equals 7. Again, we're not worried about what the actual value of x is, although we can find it. The answer here is x minus 2 is equal to 7. Okay, let's do another single variable linear equation. In this one, we want to know what is the value of x plus 5, and we can see that we have the same binomial expression x plus 5 on both sides of the equation. So instead of distributing or any other technique, we could actually solve this very quickly and accurately by subtracting x plus 5 from both sides of the equation. So that'll end up looking like this. We'll have 4 times x plus 5 minus x plus 5 is equal to 27. From here, we could combine our like terms, so we are left with 4 minus 1, because this is the same thing as a 1 in front of the x plus 5, times x plus 5 equals 27. Now we are left with 3 times x plus 5 is equal to 27. From here, we just simply divide by 3 on both sides of the equation, and we are simply left with x plus 5 is equal to 9. So again, we're concerned with what x plus 5 is equal to, not actually just x isolated by itself. As we can see here, that is 9 for x plus 5. Okay, it's time for another practice SAT single variable linear equation. As we can see in this equation, we're trying to find the value of x minus 1. And again, we can see that we have the same binomial expression x minus 1 on both sides of the equation. So again, instead of distributing or doing any other technique, to solve this really accurately and quickly, we can actually treat x minus 1 as a single unit and therefore subtract 4 times x minus 1 from both sides of the equation. So it'll look something like this. We'll have 7 times x minus 1 minus 4 times x minus 1 is equal to 21. From here, we can combine our like terms, which will give us 7 minus 4 times x minus 1 is equal to 21, which leaves us with 3 times x minus 1 is equal to 21. And to find x minus 1, we just simply divide by 3 from both sides of the equation, and we are left with x minus 1 is equal to 7. So again, we're concerned with what x minus 1 is equal to, which is 7, not the actual value of x.